Okay, since we were so rushed in class today, I thought I'd take a little time to go through an example, and we can do it a little more slowly. So we have a data set here. You can see that we have 12, 40, 20, 50, 30, 20, 70, 30. Those are our data points. And there's how many of them? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of those data points. So, if we were asked on a quiz to find this, all that is saying is the summation from the first data point to the last data point of all our data. So in this case, that would be like saying x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8. Adding all those data points. That's what this says. So let's do that. 12 plus 40 plus 20 plus 50 plus 30 plus 20 plus 70 plus 30. And when I add all of those together, which I've already done, I get 272. So that's what this is. It's 272. That's all the data points added up together. Now, the reason I would even do that, the reason I would add all those up is in order to calculate mean absolute deviation, I've got to know what the mean is, or the mu. So what is the mu? Well, the mu is this. It's all of my data points from 1 to n added up together and divided by the total number of data points I have. Well, I know everything I need to know about that, because when I add all those up, I get 272. And the number of data points I have is 8. So I divide 272 by 8. And when I divide 272 by 8, I get a mu, or a mean, of 34. So my mean in this case is 34. Now, if I want to go and start calculating what my mean absolute deviation is, which is what I'm eventually trying to do, the first thing I have to do is figure out this. And all that is saying is that's my distance from my data point to the mean. How far away are each of these data points from the mean? So in this case, my mean is 34. It'd be the absolute value of 12 minus 34. In this case, it'd be the absolute value of 40 minus 34. In this case, it'd be the absolute value of 20 minus 34. The absolute value of 50 minus 34. The absolute value of 30 minus 34. The absolute value of 20 minus 34. The absolute value of 70 minus 34. And the absolute value of 30 minus 34. So, if you do that on a calculator, you can do it in your head. I'm going to have to, one way or another, do all this. So I will do 34. Oh, not yet. This is 22. This one's 6. This one's 14. This one's 16. This one's 4. This one's 14. This one is 36. And this is another 4. All right? So, this one's 22 away, 6 away, 14 away, 16 away, 4 away, 14 away, 36 away, and 4 away. Great. So now, in order to calculate my mean absolute deviation, the formula we had is we would be taking the summation from I equals 1 to n of the absolute value of my data point minus my average, which I've already calculated on that table. But I have to divide it all by the number of data points I have. So in this case, I'm going to have to add up all these numbers and divide by 8. So let's do it. 22 plus 6 plus 14 plus 16 plus 4 plus 14 plus 36 plus 4. So let's do that. I'm going to get out my calculator. 22 plus 6 plus 14 plus 16 plus 4 plus 14 plus 36 plus 4. I get 116, but I have to divide that by 8, by the number of data points I have. So 116 divided by 8 gives me 14.5. So I have a mean absolute deviation of 14.5. And that's how you calculate it. It's really pretty easy. Just find your mean, the way we've always learned to find means. Find out how far each data point is from the mean. Add up all those differences, which were these numbers right here, and divide by the total number of entries we had, which was 8. And we get our mean absolute deviation of 14.5. Okay, great. There's one other thing I just want to go over real quickly, because I know we did it briefly and didn't get much practice with it. And that is the concept of outliers when we were talking about box and whisker plots. So if we were given a set of data like this, and we wanted to make a box and whisker plot and figure out all the things like interquartile range, upper extreme, lower extreme, max, min, let's look at what we do. Our first step is always ordering the data. So we would go 4, 6, 8, 11, 12, 14, 17, 18, and 35. And the way I would normally do that is I'd cross out as I go. 4, 6, 8, 11, 12, 14, 17, 18, 35 to make sure I got them all, and I did. Now I've got to figure out what the median is, and that's just the one in the middle. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know the fifth data point is going to be my median, and it's going to be 12. All right? Now I've got to figure out my first quartile, or we could call it Q1, or we could call it the lower extreme. And the way I do that is I look at the remaining data that is below my median, and I go halfway through it. And I have to take the mean of 6 and 8, which is going to be 7. Now let's look at my upper quartile, on my upper extreme. I'm sorry, this is lower quartile. And let's look at my upper quartile, or Q3. I'm going to look at my data points here, 14, 17, 18, 35. I'm going to have to take halfway between, and that's going to give me an upper quartile of 17.5, because that's the mean of 17 and 18. My min is 4. And right now, my max, or my upper extreme, and this would be my lower extreme, my upper extreme, my max is 35. I'm going to hold on a minute, because when I look at that 35 looks really high. And I really need to determine if it is an outlier. So to do that, first we have to figure out our interquartile range. So let's do that first. If I can number this line, I've got to go from 4 to 35. So let's make this, I don't know, 5, 10, 15, 20, 25, 30, 35, 40. And that's fine. And now I'm going to do my box. So my median is 12. That makes it right about here. My lower quartile is 7. Puts it about here. My upper quartile, 17.5. That puts it about here. So now I have a box. Sorry. I have a box, and I'm going to just pause 1 second and come right back. Okay, so I am back. Let's get this back to a full screen view. Okay, so I've got my box of my box and whisker. This is my interquartile range. So to calculate my IQR, I'm going to take 17.5, which is this upper point, and I'm going to subtract 7, that is my lower quartile, and I'm going to get 10.5. So my IQR is 10.5. In order to figure out if I have an outlier, I need to multiply my IQR times 1.5. So 10.5 times 1.5 gives me 15.75. I need to see if any points are either 15.75 above Q3 or 15.75 below Q1. I know they're not 15.75 below Q1. I can look at that. Here's Q1, 15.75 below, it would be way down here, it'd be in the negatives. I know it's not that. So I'm not going to worry about that. But I am a little bit worried about this 35 right here. So let's see if that's too high. I'm going to have to take my Q3, which is 17.5, and add to it 15.75. And that gives me 33.25. Anything above 33.25 is going to be an outlier. And look at this. 35 is above 33.25. So the way we're going to handle that when we complete our box and whisker is my upper extreme is now going to become the next highest data point, which is 18. And my outlier is going to be 35. So the way I'll graph that is I just put an asterisk or a little star where my outlier is. I now put my upper extreme right here at 18 and do my line. And I put my lower extreme here at 4 and do my line. And there's my box and whisker, and it reflects this crazy outlier that I have way out there. So that's how you handle outliers. If it had turned out that this wasn't more than 1.5 times the IQR, then I would have kept my upper extreme at that data point, but I had to move it because it was above. Okay. Hope this helped. See you guys tomorrow, and good luck on your quizzes.